All right, today we're going to tackle one of these great derivative rules called the product rule. So we talked about power rule, and now we're on to a new rule called product rule. And it's just like it sounds. Product, of course, is what happens when you multiply two functions together. So we have to be careful that we're actually multiplying functions. So I just want to be clear, a function would be something in terms of x, like f of x times g of x. And you're going to see me do this a lot. I'm going to use a lot of brackets and just identify the first function and the second function. So things may or may not have the time sign between them, because obviously when you write two things next to each other, you don't always need a time sign. But I'm going to stress using the brackets throughout discovering product rule. So I just wanted to talk about a few things that are product and a few things that are not product. So let's see. So let me give you 3x squared times negative 5x cubed. And then I'm going to go ahead and I want you to put some brackets in. We're going to say it's this product times this product. Notice there's an x in this bracket and an x in this bracket. That is the idea. You have to have two functions in terms of x. There has to be x's on both sides. So maybe pause that and write that down for yourself. You need x's on both sides. Let me give you another example. I could say 7x sine of x. Okay, and I'm going to use my brackets to distinguish the first term and the second term. The first term is 7x, and there's an x in there. And my second term is sine of x, and there's an x in there because, again, we need x's on both sides. So to show you something that's not product rule would be saying 3 times the sine of x. And again, I just want to highlight with brackets here. The first term is a 3. The second term is the sine of x. This has an x, but this does not have an x. Therefore, this is not product rule. So I really want to stress, to be product rule, you have to have an x on both sides. Okay, so here is the notation, the rule for product rule. So I'm going to say if I want to take the derivative, so d dx, so I'm deriving with respect to x, the derivative of f of x times g of x. And again, notice this is product because I have x's on both sides. I have my x here and here. So this is what makes it a product. This is equal to, so I call this the first term and this the second term. It's the first term, so I'm repeating the first term, times the derivative of the second term. So the derivative of g of x is called g prime of x, plus the second term, so that's my g of x, times the derivative of the first term. So the derivative of f of x is f prime of x. So it might be worth jotting that phrase down. So it's the first times the derivative of the second plus the second times the derivative of the first. Now, one nice thing is it's not imperative that you do it that way. You could do the second times the derivative of the first plus the first times the derivative of the second. The idea is that you need one and the derivative of the other plus the other and the derivative of its opposite. Okay, so again, this is just how I say it to myself. First derivative of the second plus second derivative of the first. And I kind of just keep repeating that to myself. So let's take a look at example 1. So my first question is it product? Are there x's on the first and second term? So again, I'm going to really stress, I know there's parentheses, but I'm going to put a bracket. There's my first term, and here is my second term. And both of them have x's in it. So I know I can do product rule. So I'm just going to keep using that phrase. First, so this is going to be my dy dx. I'm just going to rewrite my first term times the derivative of the second. So I'm just applying the power rule. So x squared becomes 2x plus 3. That becomes a constant. First times the derivative of the second plus the second. So I repeat the second term times the derivative of the first. And I'm going to go to this blue guy and take its derivative. So that's my 6x minus 2. And as far as calculus goes, your calculus is done. Now it's literally just cleaning up some simple algebra skills, but the calculus part is done. I will take the time to slow down and just talk about cleaning up again. But calculus is done just algebra. So I'm just going to FOIL, I guess, as you could call it, distribute this out. So that's going to become 6x cubed plus 9x squared. What is that? Minus 4x squared minus 6. Okay, so I put those together, and then I have a plus sign. Now I have a trinomial times a binomial, so I'm just going to distribute this through, I guess. So that's going to get me 6x cubed minus 2x squared. And then I'm going to distribute the next one through. So plus 18x squared minus 6x. And then I'll do the last one. It's going to be minus 24x plus 8. And then I'm just looking to put like terms together. So again, like terms are terms that have the same terms, I guess. So the x cubes can go together, the x squareds can go together, etc. I'll just switch some colors here. So here's an x squared term, x squared term, x squared, x squared. Then just the x's can go together. And then lastly, just the constants can go together. Okay, so I just want to slow down and put all of those back together, add my like terms. And I think I just caught my mistake. I think this there should have been negative 6x. Good thing I'm slowing down here. So these purple ones are not like terms. I take that back. I need my orange. This should have been orange to put my x's together because I think that gets me negative 36x. And then I should just have a plus 8. So as you can see, I just made a mistake, and that is where most mistakes happen. It's not in calculus because calculus really isn't that bad, memorizing that product rule. It's just kind of the cleaning up of the algebra. So we'll talk another one out loud together. So again, I'm going to bracket in the first term, and I'm going to bracket in the second term, and I'm going to say, do I see x's on both sides? The answer is yes, so I'm going to apply the product rule. So g of x becomes g prime of x, and I'm going to go, okay, it's the first plus the derivative of the second, plus now leave the second, times the derivative of the first, which is just 2. So we do have to make sure that we have that power rule down, of course. And now we're just on the cleanup. So again, calculus is over, and we're just going to clean up. I'm just going to distribute this through. So my g prime of x, let's see, that's 2 times 3. So I got 6x cubed plus 3x squared. And then I'm going to distribute kind of that through. So plus 2x cubed minus 2. So what does that get me? 8x cubed plus 3x squared minus 2. And we have our derivative using product rule. All right, so why don't you copy this question down, pause it, try it on your own, and we'll compare. So I checked myself. I do have a product rule. I have x's on both sides. So I did first derivative of the second plus second derivative of the first, distributed and cleaned up to get a derivative of 4x plus 3. Now, some of you might be questioning, well, do we have to use product rule here? Couldn't we just take these two things and multiply from the beginning? So let's go ahead and do that. Let's say f of x equals, and let's just rewrite this function and clean it up from the get-go. So if I go ahead and clean that up, so no calculus, just foiling. So that's going to get me 2x squared minus 5x plus 8x minus 20. And if I clean that up, I get 2x squared plus 3x minus 20. And now I go to take its derivative. I don't have a product at all. I just have the power rule because these are 3 separate terms. So I could just take this derivative and say that's 4x plus 3. And notice how I got the exact same answer. So sometimes, you look at a question and maybe it's easier to do it without the product rule. Obviously, our goal is to practice it today. But just for future reference, you may not need to use it if it's as simple as this. All right, I'm going to go ahead and tweak my question 4 here. Write the equation of the tangent line and the normal line at x equals negative 4 to this function g of x equals x plus 1 squared. All right, so I'm going to go back to the key question. I want the equation of a line. All right, I need the equation of a line. So I'm going back to I need, y minus y1 equals m times x minus x1. All right, I need an equation of a line. So what did they give me so far? They gave me the x value. So if x is -4, the first thing I would go get is the y value because, of course, I need a point. So I'm going to substitute in -4, and I get -4 plus 1 squared. So -4 plus 1 is -3 squared, makes that a 9. So I know this is the point, -4, 9. Now I need the slope. Okay, so that's where calculus comes in. To find the slope, I need to take the derivative. So I need to find g prime of x. So I'm going to write this function down again, x plus 1 squared. Now, I don't want you to get tricked. This is not power rule because power rule has to be x to the n power. It can't be a quantity to the n power. It has to be just the variable x. So this is not power rule. So I do have to rewrite this function g of x. And I have to say, okay, this is really x plus 1 times x plus 1. And now I can say, okay, I said the word times, and I have an x on this side and an x on this side, so I must be using the product rule. So let's go ahead and evaluate g prime of x. So I'm going to say, okay, it's the first times the derivative of the second. The derivative of x is just 1, so you can put it in or not, plus the second times the derivative of the first, which again is 1. So I have g prime of x equals x plus 1 plus x plus 1. So g prime of x is equal to, I have 2 x's plus 2. And now I want the slope at x equals -4. So g prime of -4 is equal to 2 times -4 plus 2. So that's -8 plus 2. I get -6 for my slope. Okay, so now I can easily answer the question. I need the tangent line and it said the normal line. So remember, normal is just that fancy word for perpendicular. So let's go ahead and write our tangent line. So y minus y1, so y minus 9 equals my slope of -6 times x minus -4 becomes a plus. There's my tangent line. Then I need the slope for the normal line, which is almost the same, except I have to change the slope. I have to do that opposite reciprocal. So that's going to become a positive, and the reciprocal of 6/1 is 1/6. And there you have it. We wrote the equation for both the tangent line and the normal line. All right, number 5. So do I need product rule or not? So again, I'm going to say, okay, the first term in the brackets kind of help is r squared. The second term would be 5r cubed plus 3. And again, instead of calling it f of x, they're calling it f of r. And that just tells you r is the function, the variable in the problem. So I think you could do this 2 ways again. You could use product rule, which is what we're going to practice today. So f prime would equal the first times the derivative of the second. Bring that 3 down, so 15r squared plus the second times the derivative of the first. And again, calculus is done. Product rule is pretty straightforward because you're just using the power rule inside of it. And we'll just clean this up. F prime of r. So that's going to get me 15r to the 4th plus 10r to the 4th plus 6r. So my f prime of r looks like 35r to the 4th plus 6r. And we're done. Now again, did you have to use product? Well, I think you could have rewritten this f of r, and to take this r squared and distribute it through. So it would be 5r to the 5th plus 3r squared. And now look how simple that derivative is. Just derive that function. And good thing I did that because clearly I can't add today. I don't think this is 35. I think this is 25 r to the 4th plus 6r, because I should be getting the same answer. 25 r to the 4th plus 6r when I just use my power rule there. So apparently it's a great idea to check yourself, since I can easily make a mistake adding or subtracting. Boy, has summer gotten to me. All right, let's give 6 a whirl here. So I've got my 2 terms and I have x's on both sides. So I'm going to apply that product rule. Now the first thing I'm going to do, because everything's not in terms of a power, I will rewrite that f of x for myself. Remember, the square root of x is really x to the 1/2. So I have my first term times my second term. All right, so f prime of x equals the first term, x to the 1/2, times the derivative of the second, so that's 6x, plus the second, times the derivative of the first, so 1/2 x to the negative 1/2. Now, again, before I substitute a number in, I'm going to clean this up because it's a little scary looking plugging things into all these fractions. So this just goes back to the square root of x times 6x plus, let's see, this is going to turn into a fraction here because I have the negative exponent and I have a 1/2. So I'm just going to write a fraction down for myself. All right, this 3x squared minus 3 is going to go on top because technically that's over 1. I have my 1/2, and then this is going to go to the denominator as the square root of x. And then I can carefully plug in the 4. So this becomes, I'm going to do a little mental math here, guys. The square root of 4 is just going to become 2. And I'm going to do 6 times 4, which is 24, plus, all right, I'm going to do the bottom because it looks a little nicer. The square root of 4, again, is 2. 2 times 2 becomes just 4. All right, and we'll do some scratch work over here. 4 squared, so I have 16 times 3, so that's 48. And then I want to subtract 3, so I'm going to get 45. Okay, and what's nice about the AP is you don't literally have to clean anything up. This is full credit, and we're just going to stop there and call that good. Now, obviously, you could multiply and get common denominators, but we are good as far as we need to be right now. All right, throughout the AP, you're going to see a lot of things in terms of function notation. So the question here is to find f prime of 4. So clearly, the prime sign is telling me to take the derivative, and then the 4 is telling me to plug in 4. So I'm going to substitute in. But first, I have to take the derivative. Then they give you a key here. When you see these things, you can plug them in, but not until you see them. So question A, f of x equals g of x minus h of x. So I want to find f prime. So I'm going to derive this side. F becomes f prime. G of x becomes g prime of x. H of x becomes h prime of x. Now I'm going to substitute in 4. So I've got f prime of 4 equals g prime of 4 minus h prime of 4. So f prime of 4 equals, now g prime of 4, don't get scared because it's up here in the key. G prime of 4 is negative 2 minus h prime of 4, which is 5. Negative 2 minus 5 is negative 7. All right, B. So again, I want to derive. So f of x becomes f prime of x. G of x becomes g prime of x. So now my question is, this does say 2 times h of x, but do I need product rule? 2h of x. So if you bracket in your first term and your second term, do you have x's on both sides? No. So you should not be attempting a product rule here. This 2 is just called the coefficient, and it just stays there because it's just a number. So I just get 2 and then the derivative of this term. So 2h prime of x. So again, if it's a coefficient, and maybe jot that word down for yourself, coefficient, it just stays there. And you drive the other piece. So now I can find f prime of 4. So that's g prime of 4 plus 2h prime of 4. So f prime of 4, let's see, my g prime of 4 is negative 2. And then I have 2 times the h prime of 4, so 2 times 5. So I have negative 2 plus 10. It looks like a positive 8. Let's try, I think there's 2 more that go with that. So I have f of x equals h of x plus 2. So why don't you pause it, try it on your own, and then we'll compare. So I've got f prime of x equals h prime of x, and then 2 is a constant, so it just disappeared. So f prime, I guess there should have been a 4, equals 5. And then the last one, I have f of x equals g of x times h of s. I'm going to bracket in the first and the second. And yes, I see an x in the first. I see an x in the second. So again, why don't you pause it, try product rule for yourself, and again, we'll compare. And I think I got 17. Hopefully I plugged my numbers in correctly. So I have my first derivative of the second plus second derivative of the first plugged in my 4s, plugged in my values, and I hope that matches up with yours. Last question here, we'll just review taking first derivatives and then second derivatives. So again, the y prime is saying just take the first derivative. So I'm going to go ahead and bracket in my first term and my second term. And yes, they both have x's. So I can go ahead and apply the product rule. So I have the first term, which is x to the negative 2, times the derivative of the second. Excuse me. So e to the x cubed. Remember, e is just a number. It's a constant, so it's going to stay. So my derivative would be 3ex squared, and then the 3 is a constant, plus the second term, ex cubed plus 3, times the derivative of the first, negative 2x to the negative 3. So let me keep cleaning this up. If I multiply these two terms, now I can multiply and add the exponents. So this coefficient is a 1, this coefficient is 3e. And a negative 2 and a positive 2 make 0, so there are no x terms, it's just 3e, which is handy. I'm going to distribute these through. So then I'm going to get minus 2e, and again, the x cubed and x to the negative 3 cancel out because they add to 0. When you multiply, we add exponents. And then when I multiply these guys, I get negative 6x to the negative third. So all said and done, 2e or 3e minus 2e makes e minus 6x to the negative third. And I could rewrite that as e minus 6 over x cubed. So then if I want to take the second derivative, I'm going to use, of course, the nicer version here, this guy, because I have to rewrite it back into this. And I'm going to derive that. So e is a constant, so its derivative would be 0, so it would be gone. And then I'm going to get a positive 18x to the negative 4th. So I can rewrite as that 18 over x to the 4th. Well, we've got a little bit of practice for you, and please again hit us up with some questions.